Okay, let's try to do this quick. Welcome to day 109. The class a bit, so let's do the parser stuff, but we need to like start making the AST. So let's do oh shit, package AST, and let's also make the parser, make the parser, and then touch parser, where does that go? And package parser. So this one's a little bit different, a little bit more conceptually more difficult to make. So we're gonna be parsing let statements, and then the way the book described it was is to kind of break down what a let statement gets boiled down to, you know. So there are two types of nodes we're gonna make. A node interface, right? And a node can be either a statement or an expression. A statement is just let's see. So like a statement is a collection, I guess. I'm not sure. What is it? A statement is a collection of an identifier and expression. For example, a let statement, right? An identifier and expression. Yeah, statements are things that let you bind a value to a given name. Binds the value 5, like let x equals 5, that's a let statement because you bind the value 5 to an x. So our job is to do let statements. So we can bind a function to the identifier add. So what does a statement consist of? The identifier, or at least let's be more specific. What is a in this case we can see the statements through let's see how a let statement is broken down, right? A let statement has two components, or three components, I guess. The let, the keyword, the identifier, then the assign, then the expression itself. So what are expressions? Expressions are anything that produces a value. Statements don't. So let equals 5. 5 is the value. 5 produces a value, right? Yeah, the value it produces is 5. Return 5 is a statement. Like return 5 statement doesn't produce a value, but add, like a function add 5 does, that produces a value. This distinction, expressions produces value, statements don't. Changes depending on who you ask, but it's good enough for it needs. So let's just do really quick the interface we have, right? We have type node interface, and it's gonna have a few things. It's gonna have a few things. It's gonna have, well, actually, only one thing is if anything that implements the token literal, which is only for debugging purposes. So yeah. But interface, yeah. So we have this, and so we're gonna break it down into statements and expressions. So we're gonna make some, we're gonna make like a few, all of this shit, right? So we're gonna have the statement and the expression. And of course it's just gonna be like, obviously it's a node. All statements are nodes and expressions are nodes. But they also have some dummy functions to kind of implement. So some nodes are going to be statement interfaces, implement the statement interface. Some nodes implement the expression node, right? So this is kind of our types we have, right? So here's an implementation of a node, right? You have type program, which is just literally a list of statements, right? Statement, right? We'll add some. So we want to implement. What do we want to implement? We want to implement some stuff to it, right? I think it's good to also bring the token here. Import github.com / boat Noah / monkey / token. Very nice. Actually, I need to get mod tidy. What am I saying? Go mod tidy. Alright, so let's actually make some functions for this program. This is the token literal thing, right? We have a few things. So a program is a node. So this is a node, right? So we'll be satisfying the node portion of it. So token yeah, so what does this do? That all it does is okay, I see. So all it does is call the function recursively. I think so. Length of p dot statements, which is the first one, and then we call it token literal. Right? So return p dot statement 0 dot token literal. Oops. Right. Else, well, what am I saying? This does not make sense. Length of that is greater than 0. I don't know. So we return that, right? I guess this recursively goes through it, right? Let me try to read this. So program node is going to be the root of every AST our parser reduces. Every valid monkey statement is a series of statements, makes sense, The statement are contained in program.stance, which is a slice of an AST node that implements the statement interface. Exactly. Like statement interface? I thought this was the node interface. Oh wait, everything inside the. Okay, yeah, I'm stupid. Yeah. A program consists of a bunch of statement nodes, right? With these basic building blocks are AST construction defined. Let's think about what a node for variable binding is in the form of let equals 5 might look like. Which fields does it have? Definitely one of the names of the variable, and it also needs a field that points to the expression on the right side of the equal sign. It should be able to point to any expression. It's just to point a literal value. That makes these fields one of the identifier, one of the expression that produces the value in the let's image and one for the token. So let's actually make an example of a statement node, right? So a statement node is like a let statement. So let's make an example of one, right? So let statement, struct. And then what does a let statement have? The identifier, right? Or like the token, right? The token, which is the token dot token. Crap. Token dot token, right? We also have the identifier or the name. What is it? Name and value. Yeah, so they call it name. I think, what is that type? Identifier. And then we have value. This one has the expression. Yeah. So what is this identifier? Where's identifier? I think I'm missing something. I'm not sure. What time is it? Ooh. Oh, I lost the thing. Right. I don't have anything with identifier. What is this? I think I'm confusing something here. Okay, I see. Makes more sense now. So yeah, we're gonna take a let statement, right? Which consists the token, which is the token.let, right? And an identifier, which is like the name. And then the value, which is an type of expression, right? Expressions give value, right? Identify. Okay, so let's implement. So first, what is a let statement? Is a type of statement interface. So we have to implement those functions. So let's do ls dot let. So we have a few things. We have this one. Okay, after this I gotta dip, so let's just do this quick. Right. And let's do the statement node. Well, I mean the token literal. So all, because it's a type of node, right? Let's do func ls dot let statement nice. Token literal. So this one I can just ls dot, or I guess return ls dot token. Well, what would be a literal of the let statement? Is it the value? I see. I mean, what is the literal? So the literal is the let, I guess. Token dot literal. Right? That was my thought. Then the statement node, we have to obviously do that. Let me put this up here. But I think that's a good starting point. I'm gonna read up on this more so I don't get too confused, but it's starting to make things more similar, but I don't go to class, so thanks for watching, guys. I'll see you for tomorrow's video. Peace.